This video is about half-angle formulas. The directions you're going to be given are to use a half-angle formula to find the exact value of the expression. So first, what we need to do is examine your half-angle formulas. Now you should have a formula sheet sitting out, and these are the formulas that are also on there. We've got the sine half-angle formula, the cosine half-angle formula, tangent half-angle formula, and you should notice that they're not all the same. There's a plus or minus symbol in front of these, both the sine and the cosine half-angle formulas. We'll be looking at that. And then there's two different ones for tangent. They're actually equivalent. There's an identity proof where you could show that those two are the same, but they're the same. It doesn't matter which one you choose. So for the first example, before I go on to that, sine of a over 2 is equal to sine of 1/2 a. And that should be somewhat obvious, but if your formula sheet looks a little bit different than what I had just shown, it's really just the same thing. Okay, so now we're into the example. It says use a half-angle formula to find the exact value of the expression. We're going to do sine of 5 pi over 12. I'm going to try to walk you through the steps. So the step one is to find the appropriate half-angle formula and choose the plus or minus sign based on where the given angle is. And the given angle is the angle that's inside the trig function. So in this case, 5 pi over 12. So where is 5 pi over 12? That's the first question you need to ask so that you can use the correct formula. So 5 pi over 12, where is it? Well, you want to think about the unit circle. It's definitely not on the unit circle, which is the problem, because if it was on the unit circle, we would just read the y value since it's sine. That's not the case, so we have to examine that. So 5 pi over 12 would be approximately in the first quadrant, approximately right where I drew that in that other circle there. All right, so since it's there, we are going to use the positive part of the half-angle formula for sine. So since it's in quadrant 1, sine of 5 pi over 12 will be positive. We're going to use the positive part of the sine half-angle formula, not the negative one. We're just going to ignore that. So when we look at that formula down there, we're going to ignore the minus part and just use the positive part. So it's important to know that when we use the positive part, we don't really need to write the plus sign. It's just implied that it's positive if we don't write it. All right. And so now we're moving on to step 2. Step 2 is to rewrite your expression, your original expression, in the alpha over 2 form, a over 2, and figure out what alpha is. I'm using a and alpha interchangeably because different formula sheets have a instead of alpha. It's just a letter to represent some angle. So to figure out what that is, we are rewriting sine of 5 pi over 12 equals sine of alpha over 2. And so that implies then that 5 pi over 12 is somehow equal to alpha over 2. And we need to figure out what alpha is because we're going to use that in that formula. And I put that up in the right part of this slide up here. I need alpha, and that better be on the unit circle so that I can find the cosine value of that. It's kind of the whole point of this part. So to find what alpha is, I'm going to multiply both sides times 2. The 2's are going to cancel on the right side, and then I'm going to just simplify that fraction by essentially taking half of 12. And that's going to give me 5 pi over 6 is equal to a. And that's what I'm going to use from here on out. So alpha is 5 pi over 6. And now that I have the correct formula, I've found alpha. This is actually the wrong symbol right there. That looks like a proportional symbol, but it's supposed to say alpha. We're going to plug in the values and evaluate. All right. So we're going to plug in whatever alpha was. So we had sine of 5 pi over 12. It equals sine of some alpha over 2. We know that that is 5 pi over 6, right? And if this were in degrees, it'd probably be a little bit of an easier process. You'd be able to see it a little bit easier. So now we're just going to plug it into the formula. The formula was the square root of 1 minus cosine of alpha all over 2. Alpha is 5 pi over 6. We plug that in. And now I can just use the unit circle to figure out what cosine of 5 pi over 6 is. When I look on the unit circle, cosine of 5 pi over 6 is negative root 3 over 2. So I'm just substituting that in. My next steps now are all just simplifying. So what I have to do is I have to change that number 1 to a 2 over 2. And the reason I need to do that is so that I can subtract that fraction. So that becomes 2 over 2 minus negative root 3 over 2, which allows me to actually subtract. I'm subtracting a negative, so that numerator has a plus sign there. And from here, this gets a little bit tricky. We've got a fraction on top of just a plain old number. So we've got 2 plus root 3 over 2 over 2. So we're dividing that top part by 2, which is the same as multiplying times a half. And that's exactly what that next step is. So the square root of 2 plus root 3 over 2 is now multiplied times 1/2. And so what happens there, we multiply straight across, and we get the square root of 2 plus the square root of 3 over 4, right? And I can take the square root of the numerator and the denominator separately now. And the reason I want to do that is because I recognize in the denominator, that's a perfect square. The number 4 is a perfect square. So when I take the square root, I get something nice, the number 2. And that turns out is my final answer. The square root of 2 plus square root of 3, all under that square root, and all of that under 2. And so we're really happy that we didn't have to memorize that part of the unit circle. That would have been pretty complicated. All right, so a couple other things. What about for cosine? Because I just did a sine example. We've got other formulas. So for cosine, well, it turns out it's all the same steps, right? Complete the same steps as the previous example, except in this problem, you should notice that 11 pi over 12 is in quadrant 2, and cosine's negative there, so you would want to use the negative cosine formula. And in this case, you would ignore the positive part. You know your answer needs to be negative, so there's a negative sign out front. And then tangent. So what if we did tangent of 11 pi over 12? Well, remember, you've got those two different formulas. It doesn't matter which one you choose. It's actually a little bit easier. You don't have to think about if it's positive or negative. All that stuff will work itself out, regardless of what equation you choose. You can choose either one of those. You still need to figure out what alpha is, but it doesn't matter which formula from there on out. Let's see if there are any other notes. Yeah, so this is another example. Sometimes these problems can get confusing because you've learned so many strategies. So with sine of 15 degrees, we've done this problem with sum and difference formulas. So you could solve it that way or with the half angle formula. So be careful to read the directions when you do these problems. Like 15 degrees can be rewritten as 45 minus 30 or as 30 over 2. So it doesn't matter, but your teacher, professor, whoever, your textbook might give you some specifics as to how it's supposed to be solved. The answers might look a little bit different. They should be the exact same when you solve them either way. Hope that helps.